This is the accompanying video to the blog post that we have on our Lab 651 website, which is all about Machine Learning 101. And in this blog post and video, what we're looking to do here is train our first model. So if you've read the blog post, which I'll include links in the YouTube post here, is we're actually looking to figure out what our function is. So we have a series of inputs and outputs, and the beauty of machine learning is based on the input and output, there's a certain function that the machine's going to calculate. In this example, we're actually looking at a way to convert from Celsius to Fahrenheit, but the machine doesn't know that. It has a series of input values, and then there'll be a series of output values. And over the course of us using our neural network, the machine will start to figure out, okay, this is the approximate, mapping that should happen between these values, and then we can go ahead and use a prediction and to basically test it out at the end. So what we're using here today is a tool called Colab, and it allows us to run Python notebooks inside the browser here and run them in say basically virtual runtimes. So the first thing you'll want to do is make sure that your runtime type here is set to GPU, which is the most efficient way for us to run these. That'll be the fastest for a GPU processor to run it. And then all we need to do is just run through here the notebook that I've set up for everyone. So you execute lines of code by just pushing the run button here, and right now here all we've done was import TensorFlow. You might notice this is using Python, the Python programming language. And so here we're going to go ahead and import some other things and add a logging variable. And here's our training data. So in this section here, what we do is we have a series of inputs from Celsius and some outputs to Fahrenheit, and we go ahead and print out the values of our array. So here's these values and what they equal in the input and the output. Again, the machine has no idea exactly what the formula is that these things will map, and that's what we'll end up doing further down is when we create our model. As you read through this and link off and try it on your own, I encourage you to go ahead and read through some of these details with regards to some of the machine learning terminology and some of the basic ways in which we're going to be building our various dense layers, and also using some of the sort of out-of-the-box techniques that TensorFlow provides. Again, it's a pretty straightforward model that we're going to be creating. So we just create one dense layer, and then this basically says that we're going to assemble the layers into the model. And sequential is pretty much the default way. At least it's a great place for you to start for most of your machine learning techniques, I guess, here, and with regards to assembling the layers. This allows us here, the next place is to compile the model. So we choose our loss and optimizer functions. And you might see in the blog post that I put up associated with this sort of what loss means and how we are able to use the optimizer to go ahead and feed the differences that we end up getting back through the system and allow it to essentially step closer and closer towards the actual answer. And that's what some of these things are with regards to using mean squared error and the atom optimizer. And again, there's links here for you to follow that and dig in more deeply to understand what's going on. So now what we do here is we actually train the model. And this can take a long time if you have a lot of data. We don't really have a whole lot of data. In fact, I think we have like 7 values. And what happened right here was we fed it through the system 500 times. So we ended up creating 7 times 500, so 3,500 unique data points as we fed it through our neural network. And now what we have right now here is as it's getting trained and it's going through the various epochs, which is it's another term that you can start reading about, but that's the number of times that the data is fed through the network for it to learn from. We can go ahead and use a matplotlib. It's a library to allow us to see, okay, how has it been training? And you'll see at the very beginning here, it's pretty high with regards to loss. And losses is essentially the input that came in and the output that was expected when the machine tried to learn that, how far off was it? So at the very beginning here, it's it's off by a lot. Obviously, it hasn't seen a lot of data, but over the course of time here, and each time it ends up running through, it gets closer and closer to zero. So by the end, by the time it's fed it through 500, it's getting pretty close to a loss of zero. Now it's not perfect, you'll see, but it's definitely getting closer and closer and sort of converging to that. So now what we can do is, it hasn't actually seen the value of 100 degrees Celsius, and we all know that 100 degrees Celsius is 212. So if we go ahead and take our model and say, okay, what do you think 100 is? If we run this through, we end up getting 211.31. So not so bad. It's actually getting pretty close. And as if you were to try other, you can go ahead and predict other values along the way. You'll see that it's very accurate. And so that's pretty impressive, right? We never told it the function to use. We fed it only a handful of values, and it was able to come up with a pretty good prediction that's close to what the true value would be, if it knew what the function was. So to review here, yeah, we created a model with a dense layer, and we trained it with 3,500 examples, and got a pretty good result here at the end of the day. One thing I wanted to talk about here is also the way that the weights work. And if you take a look at how neural networks work, is there's a node, and based on that node, there's either a factor that can be added, which is kind of the multiplier here, and then also the offset. So in our case here, if you dig into what the model was saying and how the weights were working with regards to the neural network, we see 1.82, which is actually pretty close to the 1.8 that's here, and then we have this offset of close to 29. So while it's not perfect, the neural network it has kind of trained itself to sort of hone in on a pretty close function to what what the Celsius to Fahrenheit uh, function would actually do. So worked out really well. At the end here, we try a little bit of an experiment. We figure, well, what happens if we add more dense networks? And we'll talk about this in future videos and future blog posts. But if we go ahead and add in, let's try something with 4 nodes, for example, and a little bit of a different input shape. And this is more or less just experimentation around with it. Let's sort of see what happens. And what happens in a lot of these cases is you'll end up getting something that's really close, as you can see here. It's actually even a little bit closer to what the true answer was, but there's like 10 variables that end up coming in, and over here we have 11 variables, and then there's 12 variables. It's a lot more complex than really what it needs to be. And so it says, this model is able to predict the corresponding Fahrenheit value really well, but if you look at the variables or the weights, for each one of these layers, they're nothing even close to 1.8, 3.2. What it's really done is it's added a lot more complexity inside the network, and it kind of hides the simple form of the conversion equation, right? The real equation was something really straightforward, which was up here, 1.8 times the input plus 32 would basically get you the output. And so while it's okay to go ahead and add in these other multiple layers, more dense units, which essentially end up being more nodes in the network, more neurons, it actually can then, while you might end up getting a better value, as you start digging in, it can become a lot more complex than really what it needs to do. So we'll talk more about dense layers in future posts. But for now, hopefully you've been able to see that it's pretty straightforward for us to take some values, use TensorFlow, make some, train the model, and make some pretty cool predictions just right out of the box. Thank you.